Alright, this video is what we call the sum and difference formulas. Basically, if we're adding two functions together or subtracting them, then we take the sine, cosine, or tangent. So, the sum and difference formulas for cosine are as follows. Pretty much if you're adding two functions and take the cosine, take the cosine of the first function, the cosine of the second function, then you take the sine of the first function, or first angle, multiply by the sine of the second angle, and then subtract. Then if you're subtracting the angles, then take the cosine, you add them. So for these first two examples, it says find the exact value of cosine. The first example is cosine of 75 degrees. Alright, remember cosine of 75 degrees. Remember, you know that's cosine of 45 degrees plus 30 degrees. So you could do the first angle, or first formula on the previous slide. So that would just be cosine of 45 times cosine of 30 minus sine of 45 degrees times sine of 30. So see sine of 30 degrees on the end, and never mind this stuff, that's just stray marks. Cosine of 45, if you remember, square root of 2 over 2. Cosine of 30 degrees, I believe is square root of 3 over 2. And sine of 45, since it's minus sine of 45 is still square root of 2 over 2. Sine of 30 degrees, I believe, is 1 over 2. So it should be square root of 2 times square root of 3 is square root of 6 over 4 minus square root of 2 over 4. Since they're both over 4, you could just combine it into one fraction. Square root of 6 minus square root of 2 over 4. Now pi over 12, or cosine of pi over 12. You know that could be, if you look, that could be rewritten as cosine of 4 pi over 12 minus 3 pi over 12. We chose these two fractions because 4 pi over 12 reduces to pi over 3, and 3 pi over 12 reduces to pi over 4, both of which are angles on our unit circle. So if we plug it into the second formula on the previous slide, that would be cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. Now cosine of pi over 3, which I believe is cosine of 60 degrees, that's just equal to 1/2. No, that should be cosine of 60. It should be 1/2 times cosine of pi over 4 is square root of 2 over 2. And then it's plus sine of pi over 3. So it would be sine of 60, which is square root of 3 over 2, times sine of pi over 4, which is square root of 2 over 2. Now, since, if you notice, both fractions have a denominator of 2 times 2, which is 4. So if we combine it into one fraction, you have 1 times square root of 2, which is square root of 2, plus square root of 3 times square root of 2 is square root of 6. So square root of 2 plus square root of 6, all over 4. Alright, here are the sum and difference formulas for the sine function. If you're adding the angles and take the sine, you multiply the sine of the first angle, the cosine of the second angle, then multiply the cosine of the first angle by the sine of the second angle, and if you're adding the angles, then you add the products. If you're subtracting the angles, you subtract the products. So for this example, it says find the exact value of sine of 7 pi over 12. Well, 7 pi over 12, we could rewrite that as just 4 pi over 12 plus 3 pi over 12. We can rewrite the sum of two angles. And the reason we chose these two angles It's because 4 pi over 12 reduces to pi over 3. 3 pi over 12 reduces to pi over 4, both of which are on our unit circle. And since we're adding these and take the sine, we can plug it into the angle sum formula for the sine. So it'd be sine of pi over 3 times cosine of pi over 4 plus cosine of pi over 3 times sine of pi over 4. Now sine of pi over 3 is just square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2, so you multiply. And then we add, and then cosine of pi over 3, which is just cosine of 60 is just 1/2. And sine of pi over 4 is square root of 2 over 2. So that would be square root of 6, and then that should be square root of 2, not square root of 3. So 1 times square root of 2 is square root of 2. Now since they both have a denominator of 4, because 2 times 2, you can put them into a single fraction and then just add the numerators. So square root of 6 plus square root of 2 all over 4. Now for this two-part example, or these two examples, for example 4 it says find the exact value of sine of 80 times cosine of 20 minus cosine of 80 times sine of 20. Alright, if we let the 80 be our alpha and cosine be our beta, that looks an awfully lot like this sine difference formula, because you have sine times cosine minus cosine times sine. So that looks like it'd be sine of alpha minus beta, which would be sine of 80 degrees minus 20 degrees, which would be sine of 60. Sine of 60 degrees is just, I believe, square root of 3 over 2. Now for example 5, it is known that sine of alpha is equal to 4 over 5, with our angle alpha being from pi over 2 to pi. And this would be in quadrant, if you realize it, quadrant 2. And sine of beta is equal to negative 2 over square root of 5, or 2 square roots of 5 over 5, with beta being from pi to 3 pi over 2. That means that angle would be in quadrant 3. So let's find cosine of alpha, cosine of beta, the angle sum for cosine, and angle sum for sine. So let's first draw our angles. Remember, sine is just y over r. So for sine of alpha, that'd be 4 over 5 in the second quadrant. So the y displacement is 4. The hypotenuse is 5, and we need to know the x-coordinate. Now you could do the Pythagorean theorem, x squared plus 4 squared equals 5 squared. Or if you recognize the Pythagorean triple, 3, 4, 5. But since the x-coordinate is negative, the x-displacement would be negative 3. Because negative 3 squared is 9, 4 squared is 16, 5 squared is 25. Now for beta, because remember that's alpha. Beta is in the third quadrant. The y displacement is 2, so it'd be negative 2 over square root of 5. We need to know, again, the x-coordinate. So x squared plus negative 2 squared equals square root of 5 squared. And I use this function because it's easier to deal with. So you have x squared plus negative 2 squared is 4. Square root of 5 squared is 5, which means x squared is equal to 1, so the x displacement is, actually it should be positive 1, not negative. And that's for angle beta. So for part A, cosine of alpha, it'd be the cosine, which is negative 3 over the range. Remember, cosine is just x over r, so it'd be negative 3 over 5. And for B, cosine of beta, cosine would be 1 over square root of 5 which would be the same as square root of 5 over 5. That's cosine of alpha. This would be cosine of beta. Part B is cosine of alpha plus beta. Remember, that's cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Remember, cosine of alpha, I believe, was negative 3 over 5. Cosine of beta was square roots of 5 over 5. Minus sine of alpha, which was 4/5. And the sine was negative 2 square roots of 5 over 5, if you plug in the values. So that'd be minus 3 square roots of 5 over 25, minus 4 times negative 2, which would be negative 8 square roots of 5 over 25. Negative 3 minus negative 8 would be negative 3 plus 8, which would be 5 square roots of 5 over 25. 5 and 25 reduced to 1 and 5, so part C reduces to square root of 5 over 5. In part D, sine of alpha plus beta, that's equal to sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Now sine of alpha is just I believe that was just 4/5. Cosine of beta was just square root of 5 over 5. And I believe that should be addition plus cosine of alpha, which was negative 3 over 5, times sine of beta. Sine of beta was 2 square roots of 5 over 5. Now 4 times the square root of 5 is just 4 square roots of 5 over 25, because 5 times 5 is 25. Then plus the negative 3 times 2, which would be negative 6 square roots of 5 over 25. 4 plus negative 6 would be negative 2 square roots of 5 over 25. So, establish this identity. Cosine of alpha minus beta over sine of alpha times sine of beta is equal to cotangent of alpha times cotangent of beta plus 1. Alright, remember when we're trying to establish an identity, take the side that looks more complicated. Now, I'd recommend starting with the cosine of alpha minus beta, that side, because you can substitute in something for cosine of alpha minus beta. Since we have the cosine of the difference of two angles, we could substitute in the cosine difference formula for the numerator. So it'd be cosine of alpha times cosine of beta minus, that should be plus, because we're dealing with the difference formula, sine of alpha times sine of beta, divided by sine of alpha times sine of beta. Now, since we have two things being added in the numerator and they have the same denominator, we can split them up into separate fractions. Cosine of alpha times cosine of beta divided by sine of alpha times sine of beta. Now, for the right-hand fraction, we have sine of alpha times sine of beta divided by sine of alpha times sine of beta. You notice here sine of alpha, sine of beta cancel out, so that just reduces to 1. Here you have cosine over sine of alpha, so that's cotangent of alpha. Not cosine, but cotangent. Now you have cosine of beta over sine of beta, which would be cotangent of beta. We've established this identity, so we're done. Alright, here are the sum and difference formulas for the tangent. Tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta all over 1 minus tangent of alpha times tangent of beta. And the same formula if you're subtracting, it's just that, remember, whatever sign is here in the parentheses. That same sign will show up in the numerator, and then the opposite sign is in the denominator. So for this example, prove this identity. Tangent of theta plus pi is equal to tangent of theta. Since we're doing the angle sum formula for tangent, it would be tangent of the first angle theta plus tangent of the second angle pi all over 1 minus tangent of theta times tangent of pi. Now tangent of pi is equal to sine of pi over cosine of pi. Now the sine of pi is 0, cosine of pi is 1, which means tangent of pi is 0. So tangent of theta plus 0, which is tangent of theta. And we said tangent of theta is, or tangent of pi is 0, so tangent of theta times 0 is 0. 1 minus 0 is 1. So this is how we know it's equal to tangent of theta. Alright, example 8 says, prove this identity. Prove this identity. Tangent of theta plus tangent of pi over 2 is equal to cotangent of theta. Now we technically could try plugging it into the tangent sum formula, but here's the problem with that. If you plug it into the tangent sum formula, ignoring what's on the denominator, because we don't even need to get that far before we run into an issue. We have tangent of theta plus tangent of pi over 2. If you try to take tangent of pi over 2, you end up with sine of pi over 2 over cosine of pi over 2. Cosine of pi over 2 is 0, sine is 1, which means tangent of pi over 2 is undefined. So, that's why we can't just use the tangent sum formula on this. You might need to rewrite it as just sine of theta plus pi over 2 over the cosine. So if you rewrite it as just sine over cosine, it would be sine of theta plus pi over 2 over cosine of theta plus pi over 2. So if we plug the numerator into the angle sum formula for sine, the denominator into the angle sum formula for cosine, we would have sine of theta times cosine of pi over 2 plus cosine of theta times sine of pi over 2 all over cosine of theta times cosine of pi over 2 minus sine of theta times sine of pi over 2. Now, we know cosine of pi over 2 is 0, so which means those values go away. Sine of pi over 2 is 1, so you end up with cosine over negative sine. Since you have a positive divided by a negative here, it'll be negative, and cosine divided by sine is cotangent. So this entire thing is equal to, that's how this entire thing is equal to negative cotangent of theta.